Okay, number 5 from 5A is a money type problem, and it's saying you have a couple options for investing. So let's take a look at what these are here. We've got option A is invest $1,000. Actually, that's true for both of them. And you get 8% at the end of each year. So that's saying after, let's say, what can we call this? The value, let's say. So the value of the investment. Actually, oftentimes it's called P for no. Yeah, let's just say value because that'll make sense. Okay, so value of investment over a number of years, T, right? So we'll call V the value of the investment after T years. Okay, so the value in the investment is going to be the initial amount of the investment times, and then we want 8 additional percent, so it's 100% plus the extra 8% every year, and we got to multiply that 1.08 in for every year that we need that extra 8% of whatever was in the account. Okay, so there's the equation for that one. Then there's option B, which is still you start with $1,000, but now it's 2% per quarter. So 2% every few months, right? Every 3 months, and it's 4 times per year, right? That's why it's called per quarter. So, okay. So in this case, uh, we could think of the value as being, actually, let me call this a different letter. Let's call this, I don't know, what comes after V? U, V, W. I'll just call it W. So it's like V, but one later, right? So W of T is going to be the 1,000, and then 1 plus 0.02. So 1.02 to the T. Now, T, if we want T to be number of years, let's see, then we really need this to be, well, if I plug in 1, then it's been compounded 4 times. So I need it to be 4 times T here. Because after 1 year, it's already been compounded 4 times. After 2 years, it's been compounded 8 times. So this fits that where T is years. So W equals value of investment after T years. Now, what you could do is you could use a different variable and say T is the number of quarters. You could do that, right? That would be okay too. But this way we can compare directly how this compares to this. So like if we think about it, like after 1 year, this will be 1,000 times 1.08 to the first. And this one will be 1,000 times 1.02 to the fourth, right? Because it was compounded 4 times that year. And then if we look at V of 2, it's going to be 1,000 times 1.08 squared. And W of 2 would be 1,000 times 1.02 to the eighth, right? So let's actually plug in some of these into the calculator and see what they equal. So if I had 1,000 times 1.08 to the first, right, that's 1080. And then if I did it to the second instead, that'll be 1166.40 because we're talking dollars again, or money. If we did one more, let's go cubed. So that would be 12. Well, let me write it out. 1,000, 1.08 cubed equals 1259.712. And over here, this would really be compounded 12 times now. So let's take a look at these. So it'd be 1,000 times 1.02 to the fourth. So that's 1082.43-ish. And then if we do the same thing again, but now it's 2 years, so it's to the eighth. I'm just going to put times 2 up here. Now it's 1171.66. And if I do it now a third year, so 4 times 3, we got 1268.24. Now, if you look at this, some people think, well, if I'm compounding at 2% 4 times a year, that's like 8% every year. But it's not. It's actually a little bit more than 8% every year. So if you kind of have options here, and sometimes when you invest money into like certain accounts, you have to look at how often do they actually compound. They often will say an overall rate for the year and say like 8%, but really it might be 8%, and then they compound it frequently, and depending on how often they compound, it's worth more. So 2% compounded 4 times a year actually makes your investment worth more than 8% just at the end of the year. Okay, if you look at it, that difference is growing, in fact. Right here, it's only $2. The next year, it's $5. And then the next year, it's $9. You can imagine after like 40 or 50 years, that grows very quickly. So, or it grows more substantially each year. The rate changes are the same, but the dollar differences grow as the numbers get bigger. Okay. So is one option better? Yes. Option B is better, right? You could kind of play around with the idea, like if I said, well, instead of 8% once a year or 2% 4 times a year, I could say 1% 8 times a year, and that would be even better. Or I could say 0.5% 16 times a year, and that would be even better. And the more often you break down that rate into like however many times a year you want to do it, the more your investment gains. It peaks at some point. At some point, you're compounding every instant. And that's where this number comes into play. Where is it here? E. There's some number called E, and I'm trying to find it on here. Here it is. And it's about 2.718. It's kind of like pi in that way. It's like a weird non-repeating decimal. Eventually we'll get to it, and we'll talk about it a little bit when we get there.